students, so for today's homework, we're reviewing for Unit Exam 1. We have the Gulliver problem. You already read it, so I'm going to go ahead and start as if you read it. You notice that a lot of things are happening here, and there's like several intervals of time where Gulliver is doing certain things. In this case, the first thing that we notice is that he's walking for 4 miles in the first 2 hours. Okay, and then it says here that he rested for an hour. After he rested, okay, he was walking at a slower pace, and he advanced 1 mile in the next hour. Okay, then he saw his friend, blah, 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 and they went on their bike, and they traveled 6 more miles, so 6 more miles, away from Gulliver's home or house in the next hour. Okay, so that's the next thing that he does. And then it says that they stayed 30 minutes after they reached that destination. They didn't go anywhere. Okay, and then after that, he's walking back home alone, and he does, after 1.5 hours, he was 1 mile closer to home. So now he's going back home. Okay, turning back. Okay, and then after that, he then cycles back, and he was home for in 3 hours. Okay, so all of those are the different time intervals. So you're going to have 1, 2, 3, 4, 5, 6, 7 different pieces of the graph where he's doing different things. Okay, let's go to letter A. It says that D of T represents the distance away from Gulliver's home in miles after T hours. Okay? And we have to explain whether it's a function and whether it's continuous or discrete. So by using function notation, obviously it's a function, but we need to explain why. Here we're talking about miles and hours. So over here it says that which one is going to be, right, our independent and dependent. And we're going to use that for the graph, right? So do the miles depend on the hours, or do the hours depend on the miles? So this would be hours for the x, the independent variable, and this would be miles from home. So this would be the y, or d of t. Okay, distance, d of t, is miles from home. You can call it distance as well. And this would be time in hours. Okay, time in hours, t, and d of t, distance miles away from home. Okay, so in order for me to know if it's a function or not, it means that for every different time period, there is only one distance. So for every input, there's one output. In other words, for every time, there's only one distance. Okay, so this seems to be the case here. Every time that it's been stamped, he is a different distance away from home. So here we're going to put, explain whether it's a function. We're going to say, yes, it's a function. There's a specific distance from home, or one distance from home. So we can put here 1, or specific. Okay? Is it continuous or discrete? Okay, so remember physically, when Gulliver is traveling away from home, like from 0 to 1 mile, or from 0 to 4 miles, he needs to physically go through every single mile in between the 0 and the 4 to get to the 4. Every single number in there, he physically goes through it. So this is a continuous function. Gulliver has to go through every possible distance distance to get to the next distance. Okay? Alright, for letter B we have to graph it. So now we need to take this story and graph it over here. Okay? And the first over here, the yellow part, he walked 4 miles in the first 2 hours. Okay? So I'm going to label, I know that it's like 4 miles, and then he goes 1 more mile, that's going to be 5, and then 6 more miles, it's going to be like 11 miles. And then he starts going back home. So I know that I need at least 11 miles over here. The time it took 2 hours for this, 1 hour for that, that's 3 hours. And then another hour, that's 4 hours. Then another hour, that's 5 hours. 30 minutes, 5.5 hours. 1.5, that's going to be 7 hours. And then 3 hours, that's 10 hours. Okay, so if I count all the hours in every single piece, if I count all the hours in every single piece and add them up, that's a total of 10 hours that he's going to be away. So when I go here, I can do it probably by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. So it'll be 0. Okay, and over here, the distance from home, I forgot what they were, but I think it's like 11 miles. So we're good to go also in ones. Okay? Alright, let's graph this piece first. So he left his house. When he leaves his house, when he's at the house, the actual house is 0 miles away from home because he is at home. So he starts at home at 0 miles and then he walks 4 for the next 2 hours. So I'm going to look here and then I'm going to say that for the next 2 hours, so for this space of time, for 2 hours he walked, so he left home, and he's going to walk, here's a ruler, he left home and he's going to walk all the way to 4. So from 0 to 4 in 2 hours time. Okay, so I'll make my line. Remember this is a continuous function, so I can get that line going. This would be my first yellow portion. Okay, from 0 to 2 hours, he walked 4 miles. My next piece says that he rested for 1 hour, so his distance from home didn't change, just time passed by wherever he was at for 1 hour. So over here for the next hour, so from hour 2 to hour 3, he doesn't move, he rests. So he's going to be resting and not moving distance. Okay, he's going to stay at the 4 mile distance away. So that will be my orange piece here. Then on the green piece, 1 mile in the next hour. Okay, so now that I'm here, in the next hour, so from 3 to 4, he walked 1 mile only. So 1 mile will be to 5 miles here. So I'll make my line. Okay, and this would be in green. Okay. Now I'm over here, and he goes 6 more miles away in the next hour. So where we are right here, in the next hour, so from hour 4 to hour 5, he walks 6 more miles. So if he's at 5 plus 6 is going to be 11. So over here at 11. So he goes from there to there in the next hour. So I'm going to go ahead and draw my line. Okay, and this would be in pink. Right, so that's that piece right here. Then he stayed there for 30 minutes. Okay, so for 30 minutes only he stayed. That means his distance didn't change. So over here would be from hour 5 to 5.5, so about there. He stays at that destination for 30 minutes. He doesn't move. Okay? Then he had to return home, and for the next hour and a half, he was 1 mile closer to home. So from there, that's half an hour, then 1 more hour, so from there to there, he's only 1 mile closer. So now he's going back home, and he's going to be 1 mile closer. So if he was here 11 miles away, now he's going to be 10 miles away. So to there. Okay, and that part is in the other yellow. Okay? And then it says here that he was tired, blah, blah, blah. He was home in 3 hours after he cycled back. So from there, he found the bicycle, and in 3 hours' time, he was home. That means that his distance from home will be 0 in 3 hours more. So we're here at hour 7, and in 3 hours, 1, 2, 3. So at hour 10, he is home. Home means 0 distance from the house. So he's home here. So I'll have to draw my final line. And this one is green. Okay? So this is what the graph would look like. Excuse me. Now it says, what is the value of d of 2 and what does it mean in the context of the problem? We don't have the equation because there are several pieces to each, so every little piece is its own linear function, right? But here d of 2 means when time is 2, when time is 2 hours, what is the distance from home? So we go over here at time 2. Here's time 2. He is 4 miles away. And you can see here, after 2 hours, Gulliver is 4 miles away from home. That's what d of 2 means. Distance when time is 2. I'm going to turn the page over. Why is d of t steeper on time interval? Okay, here's a time interval. Time when it's greater than 4 or equal to it, but less than 5. So in other words, between 4 and 5. Why is it steeper? Remember, steeper has higher incline. In this case, like he's moving faster. Why is it steeper here than from 0 to 2? Explain in the context of the problem. So let's look at 0 to 2 hours and then 4 to 5. Okay? So from 0 to 2 over here, right, this is the line, and then from 4 to 5 is this pink one. So from 4 to 5 is steeper than from 0 to 2. So we're looking at the yellow portion and the pink portion. So in the context of the problem, if we read it again, from the first 2 hours, Gulliver is walking, okay? And then from 4 to 5, he's actually riding on a electric bicycle. So if it's steeper, that means that he's covering more distance in a shorter time. That means that he's going faster here than he's going over here. Okay, so we're going to have to say that in words. Is traveling faster at interval 4 to 5 because he's riding on a bike. He's riding on an electric bike with his friend. on interval 0 to 2 minutes, Gulliver is walking. So his pace is slower. Okay, so that would be the explanation, something like this, in your own words, or exactly like that, for letter D. Letter E, how many hours was Gulliver actually traveling in this scenario? Actually traveling. So like moving. So if we go over here, we see that he's moving pretty much everywhere except for this part right here and this part right here. This where he's resting, this is a 1 hour rest. And this over here, it's the 30-minute rest. Okay? So if he's traveling from 0 to 10 hours, right? And he's resting 1 hour and 30 minutes. So travel time, or total time actually. Total time or domain here would be 10 hours. But he rests for 1.5 hours. Okay, that means that actually traveling for 8.5. We need to subtract these two in order to get the 8.5. The total time, one more time, for the whole experiment, in other words, the domain, is 10 hours time from when he left home to when he arrived home. And he's traveling most of it except for this 1 hour that he doesn't travel, he's resting, and that 30 minutes where he's not traveling, he's resting. So we need to subtract this hour and a half from the whole time he was there. And that is the end of that problem. I'm going to do the next problem in another video, so it's not too long.